Today we're going over ellipses. I don't know if plural's ellipses or not. Anyways, so again, this is like not as in-depth as we could go. Okay, so next year you're going to go a little farther with it. What is like the common word for an ellipse?
Oval.
Oval, right? Do any of y'all know how to draw a perfect oval?
Trace an egg.
Trace an egg. Yes?
Wing it.
Wing it, okay. So an oval, actually, what you do is you get these 2 points. This is a focus, and this is a focus. So together they are foci. Okay, and you have a string between them, and you're going to use that string to get the outline of your oval. You can watch this happen. Don't need any noise. So you use your pencil to tighten the string, and try again. Oh!
Yeah, try.
I don't know what just happened, but we'll try again. Okay. So use the pencil to go all the way around. And then you have to flip it over the pins because they kind of get in the way. And then it gives you the bottom half. Oh, should we watch that again? Watch it again.
No. Where's on that trick? YouTube.
Sorry to make it very dark. Okay. So, now let's actually learn about what the formulas and things are for an ellipse. The formula depends on which way your ellipse is facing. You can have a horizontal ellipse, so it's long ways horizontally. Okay, so like that's what I just drew. Or you can have a vertical ellipse, where it's long ways up and down, right? Okay, so it depends on which way the ellipse is as to which formula you use. Let's say for the one that I just did, it was horizontal, so you're going to use this column. Okay, here's the formula. Please be paying attention. All right. Let's go and label all the parts of our ellipse, and then we'll go back to the formula. So the major axis for this one is horizontal, and it just goes straight across. So that is the major axis. The minor axis is the one that intersects it. And for this one, it is vertical. That was really bad. Let me try again. Or not. That's a little better. So that's minor axis. And they intersect at the ellipse's center point. Just like circle yesterday had a center point, the ellipse has a center point. In the formula, that center point is HK, just like it was yesterday for circles. Okay, so that didn't change. The ends of these axes are called our vertices. Each end is a vertex. On the major axis, those are called the vertex, or vertices. And then on the minor axis, that one, or those two, are called a covertex, or covertices. So vertex goes with major axis, covertex goes with minor axis. Now in your formula, you'll notice up above that you have A and B. A is always horizontal, and A is the distance from the center point out to the outside of the ellipse. So that distance right there is A. So what would the distance of the major axis be?
2A.
2a. Very good. Then the minor axis, the length of half of it from the center point out, is b. So what's the length of the minor axis? with your hand. For this assignment, you're going to use cardboard to go underneath your paper so that you can poke the tacks through. The tacks will be your foci, your focuses, and then you'll use string. Make sure you cut your string long enough to where you can actually tie it around the tacks. 1 through 5 are about the ellipse you make, and then 6, 7, 8 are not about that one. It's about each they have their individual ellipses that they're about. So do it all on one paper. 1 through 8 are worth 90 points. The decorating's worth 10 points. Do this with a partner, one partner.